All right, so this is a little more difficult one that you might need to solve for a static equilibrium problem. I'm not really sure that something like this would really totally necessarily show up on the AP test, but this is good stuff to know. Like, this is all over. You could have whole courses in college on just this, okay? All right, so you're going to do the same thing like you did in the last problem. So we kind of want to start with this central point, all right, as the place of our diagram, okay? So I'm going to call this FGA, okay, because that's the force of gravity on A, all right? And then I can see here I have these two ropes, okay? So if you did the web assign already and you're talking about the tension in the ropes, this tension in this rope is the same everywhere, okay? So in effect, what you're doing is you're saying this force of gravity and this tension are equal, okay? So this tension here, right, FT, let's call it FTB, is really the force of gravity on the block B, okay? That's really the weight of block B that's pulling it around, okay? Same thing on this side, right? This tension here, if this is 1 kilogram, right, that's a 10 Newton force, so that tension is also a 10 Newton force, okay? So when you pull this around, that's going to be 10 Newtons, okay? Or we'll call this FT, just call it FT, I guess. Okay, all right, so on my force diagram, I'm going to have FTB and just FT, okay? And then I have these differing angles, 45 and 30. Okay, so that's important whenever you see a rope or something going over a pulley, right? If this is at rest, those are going to be equal, so in effect, the tension is just the weight of the block, all right? Okay, so then I want to split in my components, okay? So I have my FT, so I'll have FTY and FTX, okay, on a 30-degree angle. So I'll have FTX is FT cos 30, okay? And since I have a number for this, I'm going to go ahead and just plug it in because this problem is going to get a little bit complicated, okay? So 10 cosine 30, okay, 8.7, and then my FTY is going to be FT sine 30, 10 times sine 30, which is 5 newtons. All right, so that's on the one side. Okay, on the other side, I'm going to have my FTB. So I'll have FTBX and FTBY. And you can kind of label these things any way you want, but you just want to be, clear so that the person reading it can follow, okay? All right, so I'm going to have FTBX is FTB cos 45, okay, and FTBY is FTB sine 45. All right, and those I don't know, so I have to just leave those as variables, okay? All right, so now I want to start by redrawing my force diagram, all right? So I'm going to have my FG down, okay, and then up, I had my FTBY and my FTY, okay, and then sideways, I had those X components, FTX and FTBX, okay, and those I can see are going to be equal, right, because this is not moving, and then up, the sum of the ones facing up will equal the FG down, okay? All right, so conceptually, this is not any different than any of the other problems, okay? It's all exactly the same thing, all right? The setup is the same. You don't even have to really worry about what you're solving for, okay? You're just always going to pretty much do the same thing, all right? So to the right, I have FTBX minus FTX to the left, okay? FTBX equals FTX, okay? So we'll just leave that for now and see what happens, okay? In the Y direction, I have the FTY up plus the FTBY up minus the FG down equals 0. Okay. And then let's see what I want to do. Let me just go ahead and write it like this. I don't know if this is the best option. Okay, equals FG. Okay. All right, so now we kind of have everything set up. Now we have to go about figuring out what we know and what we want. So we know we want the FG A, okay, which I didn't call it A, but that's fine. Okay, FGA, and ultimately I want this block B, so I need to know the FTB, okay? So I have two things I don't know, all right? So FTBX, we can say is FTB cos 45, okay, equals FTX we did have a number for, okay, 8.7 newtons. We did actually have a number for that one. Oh, you see, you're not even going to have to simultaneously solve this. Thought you would. Okay. All right. And then now I can just solve for FTB, 8.7 newtons over the cosine of 45. Okay. And I just happened to be right that this was the right one to pick. Okay. But if you try to start solving it and you don't have enough information, right, you kind of run into a roadblock, just go to the other direction. Okay, you just have to go to the other direction, no problem. Okay, all right, so in this case, right, because do you see in this one I have two unknowns. I had FTB I don't know and FG I don't know. So if I had started with the Y, I wouldn't have been able to solve that. I would have gotten stuck. All right, so now that I've already figured out what FTB is, okay, then let's just solve this. Okay, FTY. Oops, I think I already had a number for that, didn't I? Okay, FTY, right, was 5 newtons plus FTB sine 45. Okay, but now I found out FTB over here, so now I can just plug this in on this side. Okay, so let's see, 12.3 times sine 45, okay, is 8.7. Oh, I already knew that. I could have figured that out already. Plus 5 is going to be 13.7 newtons, okay? And what did it ask for? The masses A and B, okay? So this is A, right? So here's the weights, okay? But they're actually asking for the masses. So if I'm going to do that, right, I'm going to have to divide by my 10 newtons per kilogram. So the mass of A, 1.37 kilograms, okay? And remember, that's the same as FG, okay, divided by 10. So the mass of B is going to be 1.23 kilograms. Okay. All right. I thought that was going to be a simultaneously solver, but it didn't. Okay. But you can see what would happen, right? If I don't know, let's see, like say I didn't know this number to put in, right? I would just have to leave that as a variable. And then I would end up with two equations that had the same two variables, and then I have to simultaneously solve them. Okay. Which might happen on the physics aviary. I need to go back and look. Okay. All right, that wasn't as bad as I thought.